So when we work with the binomial model, there are kind of two properties to each binomial model. How it defines, and x here is being used as a random variable. It's kind of like, what are we looking for? Or specifically, it's the number of successes in the n trials that we're interested in. But to define how x behaves, how to understand how the probabilities are going to distribute, we know we have Bernoulli trials and it's going to be a binomial model, but then it's going to be defined by n, which is our number of trials. And along with that, we also need to know p, which is our probability of success. With those two properties, we can understand how the distribution of probabilities behave based on how many trials do we have and what's our probability of success. Our other notation is q, which is just 1 minus p. That's our probability of failure. X we use to represent the number of successes in n trials. We also have this idea of mean and standard deviation here. So mean can also be described as expected value. So our expected value, you take the number of trials and multiply it with our probability of success, and that'll give you your expected value. And then standard deviation you can find by taking the square root of number of trials times probability of success times probability of failure. So what we're going to do is go back to our free thrower and kind of see how these probabilities work together. So she makes 82% of her baskets, and she's going to shoot 10 free throws. So what we're going to have here is 10 trials with the probability of success of 0.82 and probability of failure of 0.18. And what we're setting up here is this case of, okay, she's going to shoot 10 free throws and she has this % chance of making it in. What we can do is think about, what are all the possible outcomes here? If she shoots 10 times, what are the possible outcomes in terms of number of successes or number of free throws being made? And the idea is that she could make none of them. She could make 1 or 2 or 3 or 4 or 5, all the way up until 10. Kind of exhaustively going through that if she shoots the ball 10 times for a free throw, she can make anywhere from none of the free throws all the way up to all 10 of the free throws. Maybe she just makes 2, or maybe just 8. So we have this list of possible outcomes. What we want to know is, then if we have this probability of success attached, how do the probabilities distribute across here? And this is where we want to use Geogebra. So in Geogebra, if we go to geogebra.org and we're on this main page, what we want to do is go to classic apps and go down to probability. And when we open up probability, it's automatically going to open up on, this is called the normal model, which we're going to talk about later. But on this page, gives distributions of probabilities for us. And what we want to do is on this page, go to where it says the word normal on the screen. You can see there's a little drop-down menu. And this lets us investigate different probability distributions. So instead of the normal distribution, what we want to do is bring up this drop-down tab, and you want to find binomial. Binomial is special because it's going to change into what kind of looks like a histogram. And that's because there are these discrete outcomes. Let's set up our example for the free thrower. So we said there's 10 trials, probability of success of 0.82. So when we're on this page here, we're in binomial model, we need to input 2 values. It wants to know what is n and what is p. And it automatically starts with n as 20, p as 0.5, but we can edit those. So we have 10 trials, so we want to change n to 10, and our probability of success, 0.82. Just be sure to hit enter after you type everything in to make sure everything adjusts. But now we can see this number line of 0, 1, 2, 3, all the way up until 10. So we have these discrete cases with the idea being she can make 9 baskets, but she can't make 8.7 baskets. We end up with these discrete cases because we don't have a continuous number line here. It's that only certain events can occur. So what this has done is it's distributed the probability of certain events. So using the fact that she has a high chance of making the basket in, it's where the height of these bars relate to high probability of occurring, And we can see as it's focusing near this kind of 8.2 area, about 8 to 9 baskets is what we expect, just kind of like that 82% coming through. And it's the idea that we expect these larger values, and then you can see the bars decrease. And these are the cases where it's less likely to occur because she's so good. So for her to make, like at 0, you can barely see a height of a bar. There's basically nothing there. So there's this low probability because she's so good. So to shoot the ball 10 times and miss all of them isn't likely for her at all. In fact, it's close to impossible. So with the distribution of the bars, you can get an idea of what's highly probable and what's less likely to occur. Along this right-hand side, it gives us this table. So K right here is this idea of number of successes. So you can see here's our list 0 through 10. And so these are the possible outcomes for number of successes. And then what's being listed right next to it is the probability attached to that number itself. So that probability of her making 0 baskets, 0% chance. Probability of her making 10 baskets, well, next to is that 0.1374, so there's a 13.74% chance she makes all 10 baskets. So let's work through these probabilities using GeoGebra. This first one wants to know what's the probability she makes exactly 5 free throws. So here we're looking for this probability of X, which is representing the number of successes and N trials. We want to see where probability of X is equal to 5. And whenever you're looking for these exact probabilities, when you're in GeoGebra, that's what's happening in this table along the right-hand side. So if I want to see where probability of X equals 5, I just go down to 5, and that number right next to it is that probability. It's at 0.0177. So there's a 1.77% chance she makes exactly 5 free throws out of 10. Then what we could do is look for various numbers at once. It's like, what's the probability she makes 9 or 10 free throws? So 9 or 10. So this would bring through addition. And these are going to be disjoint events. She can only make 9 or only make 10. There's no overlap there. So what we're going to do is take this probability of 9 successes and add on this probability of 10 successes to represent making 9 or 10 baskets. So in GeoGebra, what we can do is grab those two probabilities, that 0.3017 and 0.1374. And then just adding those probabilities together, that'll give you this probability of OR, which is 0.4391. Then what's the probability she makes 2 or fewer free throws? Now with this, there's this function within our distribution down here. There are these 3 choices. This left-hand one is the left-sided, and then this is an interval between 2 values, and then you have a right-sided. So if we choose left-sided, it creates this tail to the left-hand side. So basically this one's going to calculate at a number or less than. So it's less than or equal to a number that you plug in there, and you can type in the number. So where I am right now, where it says x less than or equal to 8, it's starting at 8 and creates this tail to the left. And then what's given next to it in the notation, that 0.5608, that's the probability. So there's a 56.08% chance of her making less than or equal to 8 of the free throws. Then that middle button, the interval, is looking between 2 values. So what we could have done for the OR scenario, since those 2 numbers were next to each other, we could have made this interval of between 9 and 10. And what we can see is that 0.4392, which that 4th decimal place is off, and it is because this right-hand side is rounded to 4 decimal places. You could change the rounding rule to see more places, or being off in that 4th decimal place is not the end of the world. That's not too bad. But this 0.4392 would actually be the more accurate answer. And then right-hand side is going to be the idea of more than or equal to. So it's going to create a right-hand tail. So looking at In this case, if it's x more than or equal to 7, and we have this probability coming out of 0.9117, what that's relating to is 91.17% chance of more than or equal to 7 free throws made it. So for our example, we want to look at that she makes 2 or fewer. So for 2 or fewer, that's going to be the left-hand side. So with that fewer, what we're looking for here is this probability of x being less than or equal to 2. And do be careful here of whether or not you have equality, because that will matter. If it just said less than 2, we need to be careful with that. But because it's 2 or fewer, we include that 2 in there. So in GeoGebra, what we're going to do is, this is the left-hand side, so we need that left-sided, and then I just want to type in 2 and hit enter so everything adjusts, and what we can see is that comes out to 0. And on this right-hand side where it gives the exact probabilities, you can see what it's highlighting, because the idea of 2 or fewer is the same as the probability of making 0 or 1 or 2. So it's really adding those probabilities together. That comes out to 0. All right. So there's about a 0% chance of making 2 or fewer free throws. So that's how we can find these probabilities within GeoGebra using the binomial model. What's important is having your number of trials and probability of success set up to get those values. Expected number and standard deviation, there are these formulas up above, but if you're already in GeoGebra, it actually gives it to you in this upper left-hand corner. You can see mean of 8.2 and standard deviation of 1.2149. So you can just grab those values from there, but if you use the formula, you can get these same numbers out. So that's how we can use GeoGebra with this binomial model. Again, the book and other resources show how to use formulas for this, but I highly recommend we want to focus on the technology and more about getting these probabilities and interpreting them.